All right, this is Unit 10, Lesson 1, Operations with Matrices. Our lesson essential question is, how can you interpret matrices and operate with matrices? At the end of this lesson, you'll be able to interpret the parts of a matrix and use matrices for addition, subtraction, and scalar multiplication. Example 1, represent data with a matrix. How could the data values in the matrix represent? Matrices help organize information. For example, in the columns of this matrix represent sizes, small, medium, and large. So columns are up and down, rows are straight across. And the rows represent clothing items, shirts and sweaters. So 4, in this case, can represent 4 large sweaters. How can you refer to an entire matrix or to the elements of the matrix? A capital letter is used to refer to the entire matrix. This matrix is referred to as matrix A, or just A. A specific element can be referred to by using subscripts to indicate the row and column where the element is located. In general, A sub ij indicates the element in row I and column J. So the first number is your row, second number is your column. The subscript lists the row number, then the column number. In this matrix, A sub 3, 2 refers to the element in row 3, column 2. Or row 3, which is this row here, 4, 8, and then column 2 is 8. C, what are the values of the variables in the matrix equation? So 12, 0, 2x, 10 equals 12y, 14, 10. So equal matrices have the same dimensions and corresponding elements are equal. So in this case, both of these matrices are 2 by 2 matrix, which means they have 2 rows and 2 columns. So they're equal to one another. So A11 is 12, and so is A, which also equals 12. A21 is 2x. So remember, second row, first column. So 2x equals 14. So that means x equals 7. For here, A12 is 0, and that equals y, so y equals 0. And A22 is 10 is 10. The matrices are equal for y equals 0 and x equals 7. All right, let's try it. The entries in the matrix are the number of students on a committee. Column 1 lists girls, column 2 lists boys. Row 1 lists sophomores, and row 2 lists juniors. I want to find A sub 1, 2, A sub 2, 1, and A sub 2, 2, and tell what each number represents. So in my first one, I have A sub 1, 2. So that means my first row, second column. So my first row is sophomores, my second column is boys. So A sub 1, 2 equals 5 sophomore boys. A sub 2, 1 equals, so that's my second row, first column, 8 junior girls, and A sub 2, 2 equals 10 junior boys. Example 2, apply scalar multiplication. Cool Threads, a clothing store, uses a matrix C to represent the prices of women's clothes. So here's my matrix C equals 320, 210, 160, 240, 110, 65. The columns represents the brands, vintage, casual, and distressed, and the rows represent jeans and jackets. So in this case, we have vintage, jeans, jackets, casual jeans, jackets, and distressed jeans, jackets. If the sales tax rate is 5%, how can you use a matrix operation to find the amount of sales tax on each item? So if the sales tax rate is 5%, you can multiply each element in the matrix by 0.05 to get S, the matrix of sales tax amounts. Scalar multiplication is the multiplication of each element in a matrix by a single real number called a scalar. So in this case, S equals 0.05 times C. Remember, 5% changes to a decimal. I move my decimal over 2 places. So I can compute by multiplying 0.05 by each of the numbers in my matrix, which will give me 16, 1050, 8, 12, 550, and 325. Scalar multiplication does not change the dimensions or the headings of the rows and columns of the original matrix. So the scalar product represents the sales tax amounts for each item of clothing. All right, let's try it. In this matrix C, the rows represent prices of shirts and khakis. The columns represents the brands vintage, casual, and distressed. If the sales tax rate is 6%, use scalar multiplication to find the sales tax for each item. So I need to multiply this whole matrix by 6%. So 6% can become 0.06. I'm going to take 0.06 times C. So when I do that, my first row becomes 450, and 240, and 150. And then, let's do it this way. Yes, it will. So 450, 240, 150, and then my second row will become 6, 360. Example 3, add and subtract matrices. Cool Threads uses matrices to keep track of monthly sales. In matrices A and B, row 1 represents jeans and row 2 represents the sale of jackets, with the columns representing vintage, casual, and distressed brands, respectively, during 2 consecutive months. So here's March and here's April sales. What is the sales total for the 2 months? So the sum A plus B represents the totals sold during the 2 months. I just add the corresponding elements of the 2 matrices. The entry 25 means that 25 pairs of distressed jeans were sold in the 2nd month. So I'm going to add 14 plus 18, 11 plus 17, 28 plus 25, and so on, to get 32, 28, 53, 26, 24, and 80. The entry 26 means that in these 2 months, 26 vintage jackets were sold. Cool Threads uses matrices to keep track of monthly sales. Okay, so same thing. Row 1 represents jeans, row 2 represents jackets, and I have vintage, casual, and distressed. So I have March and April. What is the difference in the number of items sold each month? So last time we did addition, this time we're finding the difference. So we're going to subtract. So A minus B. So again, I just subtract 14 minus 18, 11 minus 17, 25 minus, or 28 minus 25. So I get -4, -6, 3, -6, 6, and -10. In the matrix A minus B, a positive number means more of this type were sold in the 1st month. A negative number means that there were more sold in the 2nd month. All right, let's try it. Consider matrices M and N. What are the matrices? What are matrices M plus N and N plus M? So I'm going to do M plus N first. So that's going to be -3, 5, 2, 0, plus matrix 6, 5, -8. Okay, when I do this, I just add my numbers together. So -3 plus 6 is 3, 5 plus 5 is 10, 2 plus -8 is -6. And then 0 plus 0.2 is 0.2. And then I can do N plus M equals 6 plus M matrix, which is -3, 5, 2, 0. Okay, and I'm going to get 3, 10, -6. Doesn't actually change anything. Okay, what are the difference? M minus N and N minus M. So M minus N. I'm taking this minus this. So -3 minus 6 is going to give me -9. And I will get 0. And then 10. And then -0.2. n minus m is going to equal 9, 0, negative 10, and then d equal 2. So again, with addition and subtraction of matrices, you just add the same elements together. So the numbers, so for m, I'm going to add m sub 1, 1 plus n sub 1, 1, and so on, or subtract depending on if you're finding the sum or difference. Example 4, understand matrix addition and subtraction. Consider the matrices below. How can you add and subtract these matrices? So I have A, which is a 2 by 3, B, which is a 3 by 2, C, which is a 2 by 3, and D, which is a 2 by 3. Which matrices can be combined using addition or subtraction? Adding or subtracting matrices involves adding or subtracting corresponding pairs of elements. To have corresponding pairs of elements, the matrices must have the same dimensions. A, C, and D are all 2 by 3 matrices, so 2 rows by 3 columns. So they can be added or subtracted in any order. But matrix B is a 3 by 2 matrix, so it cannot be combined with A, C, or D using addition or subtraction. Consider the matrices below. How can you add or subtract these matrices? How can you interpret a matrix of zeros? Every element in A plus D is 0. A matrix with all zeros is a 0 matrix. When the sum of two matrices is a 0 matrix, the matrices are additive inverses. So notice 5 plus negative 5 gives me 0, negative 7 plus 7 gives me 0, and so on. This is a 0, 2 by 3 matrix. A 0, 3 by 2 matrix would have all zeros, but it would have 3 rows and 2 columns. C, what is the additive inverse of matrix B? I solved the equation B plus X equals 0 so that X is the additive inverse of B. Think about what elements of matrix X will make every element of the sum matrix equal to 0. So in this case, here's my original matrix, 6, 5, negative 2, 0, 3, and 4. Well, what plus 6 gives me 0? Well, 6 plus negative 6 does. 5 plus what gives you 0? Negative 5. Negative 2 plus what gives you 0? 2. 0 plus what gives you 0? 0. 3 plus what gives you 0, which is negative 3, and 4 plus what gives you 0, which is negative 4. So my additive inverse is negative 6, negative 5, 2, 0, negative 3, negative 4. The additive inverse of a matrix is the scalar multiple of negative 1 times the matrix. Consider the matrices below. How does A plus C relate to C plus A? Well, A plus C and C plus A are the exact same matrix. In this example, A plus C equals C plus A. Matrix addition is real number addition of corresponding elements. Because real number addition is commutative, the commutative property of addition holds for matrices. Let's try it. Consider the matrices below, P, Q, and R. Find R minus Q. What other matrix sum or differences can be calculated? So notice that P is a 2 by 3 matrix, while Q and R are both 3 by 2 matrices. This means I can't do anything with P, but I can add or subtract Q and R from each other. So if I do R minus Q, I'm going to get a 3 by 2 matrix. So R 6 minus 2 is 4. 0.5 minus negative 2 is 2.5. Negative 3 minus 5 is negative 8. Zero minus negative 5 is positive 5. Negative 2 minus negative 7 becomes negative 2 plus 7, or 5. And then negative 2 minus 7 becomes negative 9. I can also do R plus Q, Q plus R, and Q minus R. Find the additive inverses of P, Q, and R. So again, I'm just going to take these matrices, I'm going to multiply them by -1. So I multiply this by -1, 2 by -1, and so on and so forth. So I will get P equals -5, -2, 3, 7, 0. P. For Q, I will get -2, 2, -5, 5, 7, -7. And then for R, I will get -6, -0.5, 3, 0, and 2, 2. All right, example 5. Use matrices to translate and dilate figures. In this diagram, segment AB is translated 4 units right and 2 units up to segment PQ. Also, segment XY is a dilation of segment AB by a factor of 1/2, centered at the origin. How can you use matrices to show a translation and a dilation? A, show the translation of segment AB to segment PQ using matrices. So I can write with one column, a matrix with one column can represent an ordered pair. A matrix with 2 columns can represent 2 ordered pairs, where the first row gives the X coordinate and the second row gives the Y coordinates. So point A is 2, 6, and the endpoints of segment AB are 2, 6, and 8, 4. So here's A, B, 2, 6, 8, 4. A translation can be represented as a matrix. The matrix for segment AB has 2 columns, so a matrix for a translation of segment AB also has 2 columns. Since the translation results in the X coordinates increasing by 4 and the Y coordinates by 2, I add the matrix 4, 4, 2, 2 to the matrix representing segment AB. To show the translation of segment AB, use matrix addition. My pre-image, which is my AB, plus my translation equals my new image. So the sum represents the endpoints P, 6, 8, and Q, 12, 6. B, show the dilation of segment AB by a scale factor of 1/2. I can use scalar multiplication by multiplying the scale factor of 1/2 by my pre-image, which I already found in my previous problem. So again, this represents my 2 points, my segment, my point A and my point B. So here's my A, here's my B, this is my X and my Y. Okay, I multiply 1/2 by each of these. 1/2 times 2 is 1, 1/2 times 8 is 4, times 6 is 3, and times 4 is 2. So this method can be used only for a dilation centered at the origin. Let's try it. A segment has endpoints M, 8, -7, and N, 1, 2. Use matrices to represent a translation of segment MN to segment RS by 6 units left and 3 units down. What are the coordinates of R and S? So the first thing that I want to do is actually create this matrix. So MN becomes matrix 8, 1, 7, 2. Okay. So 8 and -7, that's my X and my Y for M, and 1, 2 is my X and Y for N. And then I'm going 6 units left. So my X values, my top values, I'm going left. So I'm going this way, which means I'm going -6. And then 3 units down, so that's my Y value moving down, so I go -3. Okay. When I add these, 8 plus -6 is 2. 1 plus -6 is -5. -7 plus -3 is -10. And 2 plus -3 is -1. So that means R is 2, -10, and S is -5, -1. E, use matrices to represent a dilation of segment MN to segment DE by a scale factor of 3 centered at the origin. What are the coordinates of DE? So I'm taking 3 and I'm multiplying it by my matrix MN. So it's 8, 1, -7, 2. When I do that, 8 times 3 is 24. 3 times 1 is 3. -7 times 3 is -21. And 3 times 2 is 6. Okay, so that means D is 24, -21, and E is 3, 6. Remember, that only works when it's centered at the origin. Concept summary, operating with and interpreting matrices. Dimensions. The dimensions of a matrix are stated as the number of rows R by the number of columns C. So matrix A equals TUV XYZ. The dimensions of this matrix are 2 by 3 because it has 2 rows and 3 columns. A sub 1, 3 equals V. So I want my first row, third column, because V is in the first row and third column. Operations. To multiply a matrix by a scalar, multiply each element in the matrix by the scalar. So K times the matrix WXYZ becomes KW, KX, KY, KZ. To add matrices, add the corresponding elements. So A plus E, B plus F, C plus G, D plus H. To subtract matrices, subtract the corresponding elements. In this case, P minus W, Q minus X, R minus Y, S minus Z. A matrix can represent the transformation of a figure, such as a dilation centered at the origin of a quadrilateral. So in this case, these are my points. So remember, this first column is my X, this first row is my X values, and my second row is my Y values, and then each one of these represents a point. And I'm multiplying in this case by 3 because it's a factor of 3. And that is the end of Unit 10, Lesson 1.